Before we start getting hands-on with failover clustering, we're going to take a quick nugget here to get familiar with what it is, what it provides, the many layers and components involved, and how we're going to be working with it in the virtual lab. Let's do it. Failover clustering is the supreme high availability feature in Windows Server. It allows us to take an application like SQL Server, or a role like Hyper-V, or DHCP, or file services, and make it highly available. We accomplish this by installing that application or role onto 2 or more machines. We add in some shared storage, more on that here shortly, and then we add all of those resources into a cluster. That cluster is then exposed as a named resource on the network with its own IP address. Now, whenever our clients request those applications or services through the cluster will redirect them to the active node hosting those resources, what we call the owner. And here's the high availability part. If the node that currently owns those resources is unresponsive or unavailable, the cluster will simply transfer ownership to another node in the cluster. And because these nodes provide identical services and they're hooked up to shared storage, that transfer is instantaneous. Now, prior to Server 2016, there was only one type of cluster that we could create, and it relied on and required Active Directory. That is now known as a single domain cluster because Server 2016 supports 2 new types of clusters: multi-domain clusters and a totally non-domain cluster known as a workgroup cluster. Single domain clusters function just as they did before. In the context of a single domain, they don't require any extra configuration. It's our default cluster type, and we can use a single domain account to power all of the services and applications that our cluster hosts. Our 2 new cluster types do have some prerequisites and will require some extra configuration because they rely on DNS rather than Active Directory for discovery. The 2 new cluster types, however, do have some prerequisites, so they will require some extra configuration. The first thing you'll need to do is create a local user account on every single node in the cluster and ensure that it has the same name and password. And then you'll also need to add it to the local administrators group on each node. The second thing you'll need to do, and this is again because DNS is driving this, not Active Directory, is ensure that every single node also has a primary DNS suffix configured. And the third thing you'll need to do when you create the cluster is to configure it in Active Directory detached mode. And that way it won't create any associated computer objects in Active Directory, but rather it'll resolve the cluster network name through DNS. And I'll show you all this stuff when we get into the virtual lab in a future nugget. Arguably the most crucial component to failover clustering is networking. Because without the networking layer, well, we don't have a failover cluster at all. And this really is twofold. Number 1, isolation. Number 2, and the most important, redundancy. The whole goal of a cluster here is to eliminate any single points of failure. First up, let's talk about isolation. Now, there's going to be a lot of different kinds of network traffic occurring within our cluster, so it's a good idea to segregate it to, number 1, optimize those connections, but number 2, and more importantly, to ensure that none of this traffic could potentially impact our cluster in any way. So we'll want to segregate all of this traffic out onto their own networks. Number 1, management traffic and client traffic. Management traffic from us performing our administrative duties against the cluster. Client traffic are those applications and users that are utilizing the services inside of our cluster. We'll call that our company network. Our cluster network is also very important. This is our cluster communicating and running health checks against the nodes, as well as intra-node communication. So this is also very important to put on its own network. And finally, our storage network. Of course, we want to provide a dedicated network for our nodes to access that shared storage. The second part of this is redundancy, again, to eliminate any single points of failure at the network level. We can accomplish this on the physical network by providing our clients with multiple pathways into the cluster, usually by using multiple redundant switches. We can do this down at the storage level by providing our cluster with multiple pathways into our shared storage. We can do this using MPIO. And then for our cluster network, we'll want to make sure that we have multiple network interface cards in a team. So use NIC teaming here to ensure redundancy at the NIC level in our cluster nodes. Next up, we have our shared storage layer. And this could really be anything from an expensive fiber channel SAN to an inexpensive SAS JBOD enclosure to a dirt cheap iSCSI target just carving out LUNs out of regular old disks. We're going to be utilizing iSCSI in the virtual lab. I'll also mention when you're spinning up guest clusters, that is forming clusters out of nodes that are running as VMs on a Hyper-V host, that you'll use shared VHDXs or VHD sets. We have a nugget dedicated to that, so we'll look at that down the road. You'll also want to make sure that you eliminate any single points of failure down here at the shared storage layer. And there's a couple of ways to do this. One really cool way to do this is using SAS JBODs and what's known as clustered storage spaces. This is where we would get multiple SAS JBODs, and create a storage spaces cluster on top of it, where every single node in the cluster is connected to every single SAS JBOD enclosure, which would give us high availability up here at the storage spaces level and redundancy, as well as redundant connections down at the storage level. Another way to provide both redundancy and scalability is using a scale-out file server. And this is designed specifically for SQL Server and Hyper-V, large files that are always open. And we have a nugget dedicated to SOFS, so we'll save that for when we get there. Next up, we have the concept of quorum. Quorum is the number of failures that our cluster can withstand before shutting itself down. Now, how this works is every single node in our cluster has a vote. And as long as our cluster maintains 50% of the vote plus 1, it will remain active. If it ever falls below that threshold, the cluster service will shut itself down. Now, quorum is mainly there to prevent what's known as the split brain scenario. Let's say that we had a 4-node cluster and it got split in half, and they're all pointed to shared storage. Now we've got 2 active clusters hitting that shared location. If we were running an application like SQL Server, this would cause all kinds of problems. And this is why we need an odd number of votes. So if we ever have an even number of nodes, we can set up another witness that has a vote. And whichever side of the cluster, when the split occurred, that vote was on, that side would stay active and the other side would shut down. So in our diagram here, where we only have 2 nodes, we would need to create a witness for that third vote. And there's a couple of ways we could do it. We could create what's known as a disk witness, where we create a dedicated disk on our shared storage within our cluster for that vote. We could also create what's known as a file share witness, and that could be any SMB file share that our cluster has access to. And the third one is a cloud witness. This is where we have a blob stored up in Microsoft Azure, and that's more common when you have a multi-site cluster. Now, if you're creating a cluster with an odd number of nodes, there's nothing you'll need to do. You already have an odd number of votes, and your cluster will be configured using what's known as node majority. Now, there is a new feature added in here to Server 2016 called dynamic quorum management, and it's enabled by default. And what this means is when a node leaves our cluster, it takes its vote with it, reducing the total number of votes required to keep our cluster running, which means our cluster can run longer and all the way down to a single node. We'll look at that as well as how to manage quorum and configure a witness in a future nugget. With that, let's jump into the virtual lab and get familiar with the topology that we're going to be working with in the virtual lab throughout the rest of our failover clustering nuggets. This is the 5-machine lab we'll be working with throughout our next couple of nuggets here as we learn how to create, implement, and manage failover clusters. We've got one GUI machine in this lab, that is our administration machine. We'll be spending all of our time on this machine remotely creating and managing our failover cluster. CL1 nug and CL2 nug are going to be our cluster nodes. Notice that we have 2 of them here, so we are going to need to create that witness here for that third vote. And these are both server core machines. I figured we'd mix it up a bit. We've been working with NanoServer up to this point for quite a bit. So these are all server core machines. So CL1 nug and CL2 nug will be our cluster nodes. FS nug is our file server. This is what will act as our shared storage. So we'll create a nice SCSI target on this machine and then initiate it from both CL1 and CL2 nug. And then of course we're creating a single domain cluster here. So we have our domain controller supporting our nuggetlab.com domain. Let's start here by logging in to admin nug and take a closer look at this topology. Once the desktop fires up, let's launch Server Manager down there from the taskbar. Once Server Manager loads, hit all servers over there on the left. You can see that I added all 4 of our servers in here so we can remotely manage them here from our admin nug machine. Something you'll probably notice right off the bat here is we have 3 networks. So in our lab provider, I created 3 separate subnets on 3 different switches. That way we can isolate the network traffic within our cluster. So our one network here is our client or company network. This is the only network that can get outside. So these machines do have internet access through this one network. Our 2 network is our cluster network. So this is purely used for cluster and intranode communication within the cluster. And then our 3 network is purely for storage. So that's our storage network. So you'll see when we create our cluster, it's going to recognize all 3 of these networks and we'll be able to configure them as such. Another thing I want to point out, speaking of storage, is FSNUG has the iSCSI target server role installed. That way, we can create shared storage in the form of iSCSI disks and carve out LUNs from them. And just to show you here, if we right-click and choose Add Roles and Features, and just hit Next a few times until we get to Server Roles, expand File and Storage Services, File and iSCSI Services, there it is, installed and ready to go. In fact, one configuration we'll need to do if we head down here to File and Storage Services is right-click on FSNUG, go into the target settings, and isolate the traffic down to this network. We'll save that for our next nugget. And just to show you the disks over there on FSNUG, if we hit disks over here underneath volumes and scroll down as soon as this loads, we should see that we have one 50 gigabyte disk that we're going to use. So we're going to create our iSCSI target on that disk. So that disk will effectively act as the shared storage for our cluster. And that's about it. I did very little here to get us started, as little as possible. That way we'll be able to configure our storage layer and create the cluster all from scratch. Oh, and by the way, if you drop down the tools menu, notice that we do have all the RSAT tools installed here on AdminDoug. We'll be playing heavily inside of the Failover Cluster Manager to manage our cluster graphically, as well as PowerShell. And while you're in this lab, feel free to play around here and ping around to make sure we got network connectivity across all these networks for whichever ones they're connected to. In this CBC Nugget, we took an introduction to failover clustering. We got familiar with what failover clustering is, what it provides, the many layers and components involved, and how we're going to be working with it in the virtual lab. I hope this has been informative for you, and I'd like to thank you for viewing.